You know, some of the biggest problems we face as a planet, from climate change to discovering new medicines, they aren't just scientific challenges. They're actually giant, massive computational puzzles. And the truth is, our best computers, the ones we have right now, are starting to hit a wall. So in this explainer, we're going to dive into a totally new kind of computing that promises to solve the unsolvable.
Okay, let's take our energy grid for example. We all want to plug in more renewables, right? More wind, more solar. But the thing is, their output goes up and down all the time. So trying to balance all that supply and demand in real time, it's this incredibly complex problem that our current systems just can't handle fast enough.
Or how about finding new life-saving drugs? To find a new medicine, you have to simulate how countless different molecules are going to interact with each other. It's like trying to find one specific needle in a haystack the size of a mountain. It's a process that can take years of just slow, painful, methodical work.
And of course, there's security. Our entire digital life, everything from your banking app to your health records, it's all built on encryption. Encryption that one day could be broken by totally new kinds of threats. So we have to find a way to build a more secure future. And that means we need a whole new way to think about computing itself.
And here's the kicker. Our best classical supercomputers, they're just too slow for these kinds of problems. Trying to model a huge energy grid can take up to 48 hours, which is totally useless when you need to make changes in real time. And finding just a single starting point for a new drug, that can take 3 to 5 years. We just don't have that kind of time.
But what if there was a completely different way to compute? A machine that doesn't just work faster, but works differently. Something built from the ground up to tackle exactly this kind of mind-boggling complexity. Well, that is the promise of quantum computing.
So the magic really starts with something called a qubit. Think about a regular computer bit. It's like a light switch, right? It's either on or off, a 1 or a 0. A qubit, though, it's more like a spinning coin. While that coin is in the air, it's kind of both heads and tails at the exact same time. This weird property is called superposition, and it's the secret sauce that gives quantum computers their incredible power. So because this qubit can be a 0 and a 1 at the same time, a quantum computer can explore a huge number of possibilities all at once. Imagine you're in a maze. A normal computer would try one path, hit a dead end, go back, and try another. A quantum approach can basically explore tons of paths in parallel, finding the exit way, way faster.
Now, today's quantum computers aren't quite perfect yet. They're a little noisy. So we use them in this really clever hybrid way. First, we translate a real-world problem into a language the quantum computer understands. Then the quantum machine does its thing, exploring all those potential solutions. Finally, a good old classical computer looks at the results, refines the search, and tells the quantum computer where to look next. It's this powerful feedback loop that gets us the best of both worlds.
And this whole hybrid thing, it's not just an idea on a whiteboard. It is happening right now, all around the world, and it's delivering some truly incredible, measurable results. Let's look at the proof. So remember that energy grid problem we talked about? Well, a pilot program in Europe used one of these hybrid quantum systems to manage their grid. And the result? They were able to increase the amount of renewable energy they could use by a staggering 51%. That's a massive win for reducing CO2 emissions.
And speed? Oh yeah, let's talk about speed. In a cybersecurity case study over in the UAE, the quantum approach was more than 22 times faster than the classical computers they were using. Think about that. That's not just an improvement, that's a complete game changer.
And the money? Well, the numbers are just mind-blowing. Across just 8 case studies in finance, energy, and healthcare, these quantum solutions generated $4.2 billion in economic value. For every dollar they put in, they got more than $12 back. That is an insane return on investment.
And this isn't just a one-trick pony. This hybrid approach is being used all over the place, from optimizing financial portfolios to finding new drugs. And just look at those success rates. We're talking 85 to 94% consistently. That just goes to show how robust and versatile these new quantum methods are becoming. But beyond all the dollars and the speed, this is where it really hits home. After an earthquake in India, they used a quantum algorithm to figure out the best routes for ambulances and rescue teams. It found the optimal routes in 8 minutes instead of the 2 hours it would normally take. This one application helped save over 3,200 lives. It's just a powerful reminder of what this technology is actually for.
So, with results like these, you can bet the world has noticed. We are right in the middle of a massive global race to build and control the future of quantum computing.
And the scale of this race is just immense. In 2024 alone, global investment in quantum topped 16 times billion dollars. That's a huge signal that governments and big companies see this not just as some fun science experiment, but as a really, really big deal for the future.
So where's all that cash flowing? Well, cybersecurity and finance are definitely leading the pack. That makes sense, because they have these huge, immediate problems that quantum is just perfect for. But you can see investment in healthcare, climate, and energy is also taking off in a big way.
And all this money is just fueling an explosion in research. Look at this. The number of academic papers being published in this field is on track to more than quadruple between 2018 and 2025. This is how you know the field is moving from just theory to real practical applications.
I mean, the whole ecosystem is just massive, and it's growing every day. You've got governments, corporations, universities, all pouring in resources. But the really amazing part is that cloud platforms have opened this up to everyone. We now have over 180,000 users running more than 8 billion quantum programs a year. Innovation is coming from absolutely everywhere.
Okay, so we've seen what's happening now. It's incredible. But what's next? Where do we go from here on this quantum journey? Let's take a look at the road ahead.
First off, the hardware itself is just scaling up at a wild pace. I mean, just a couple of years ago, we were talking hundreds of qubits. By 2027, the goal is over 1,000, and by the early 2030s, we're aiming for machines with over 10,000 qubits. And every single time we make one of those leaps, we unlock the ability to solve even bigger, more complex problems.
Now, it's not all smooth sailing, of course. There are some really tough nuts to crack. Researchers are working hard on big challenges like quantum error correction, basically making the machines more stable. They're also developing smarter algorithms and creating new security standards to keep all of our data safe in this new quantum era.
So what we've really seen today is the dawn of a completely new way of computing. It's already making our energy grids greener, helping us find new drugs, and literally saving lives. The technology is here, it's getting better incredibly fast, and its impact is undeniable. The real question isn't if it's going to change our world, but how. So let me ask you, what problem that seems impossible today do you want to solve tomorrow?